Okay, so today's lesson, we have moved on to topic 2 in matter and chemical change. So this is common reactions in our lives, and then 2.1 is on useful reactions. So just a quick review from the uh, previous chapter is what is a chemical reaction. So we had talked about this a little bit in chapter 1. A chemical reaction, it's always when substances react and they produce a new substance. So that's very important. That's how you know a chemical reaction has occurred. A new substance is formed, and it's going to have different properties from the original substance. Also, it's very hard to go back to the original reactants. So for example, like when you cook an egg and you've applied the heat and you've cooked the egg, that's a new substance formed. It's very different from what the egg looked like before it was cooked, and it's you can't go back to what the original egg looked like. So you know a chemical reaction there has occurred. Also, the noises, like if you're frying the egg, you can hear the noises. There's the smells, and of course that the new substance is formed, and that you can't go back and reverse the reaction and go back to what the egg looked like before. Another example, like launching a space shuttle, hydrogen and oxygen combine during a chemical reaction, and there's energy produced and water is produced. Then that energy is taken and it's used to power the space shuttle, and then water is actually a byproduct of the reaction, which then can be used in the space shuttle. Another example of a chemical reaction is just taking an antacid tablet. Basically, an antacid tablet will contain something basic inside of it, like magnesium hydroxide, and that magnesium hydroxide will react with the hydrochloric acid in your stomach, and then to neutralize the acid in the stomach. And the products here will be neutral magnesium chloride and water. So salt, magnesium chloride is a salt, and then water is produced. So that's another chemical reaction example. Another one is just a banana sitting on your counter. It's sitting there, it's getting ripe. It starts to change color. It goes from like green to yellow to brown. That's another chemical reaction. There's a natural ripening gas known as ethylene. The ethylene triggers an enzyme production, and then the enzymes speed up the chemical reactions. So there's an enzyme called amylase. It breaks down starches into sugar. And then there's another enzyme that triggers color change and causes the softening of the fruit. And then enzymes will break down the large molecules into smaller ones. Those will evaporate into the air, and that's what we smell when the banana is ripened. So that's another example of chemical reactions occurring. Here, like household bleach, helps to keep laundry looking whiter and brighter and cleaner. And the active ingredient inside bleaches is hydrogen peroxide. Some bleaches might contain sodium hypochlorite, but both of them contain oxygen. And it's that oxygen that's responsible for the reaction that makes a colored stain colorless. Baking bread, we've already talked about baking in the previous unit, but it does come up again in chemical reactions, because again there is a reaction occurring when you cook and when you bake. So for example, for baking bread, you combine the flour, the yeast, some sort of liquid, water, milk, whatever it is, salt, and then the other flavorings, and then it's made into a dough, and it's usually left to rise. Then that dough is taken and put into a hot oven, producing a loaf of bread. So flour is usually made of cereal grains, and those cereal grains release starch and proteins when they're milled, and then when flour gets mixed with water and yeast, the enzymes in the yeast start breaking down that starch into glucose, which is a sugar. Other enzymes are going to react with some of the glucose molecules, and then that carbon dioxide gas is produced, as well as ethanol, which is an alcohol. The carbon dioxide is the gas. That's the part that's going to bubble up and cause the dough to rise. And then when it gets heated, pockets of gas in the dough expand, and that's what gives the bread an airy texture. The alcohol that was a byproduct will just burn off during the baking process, but it leaves behind delicious flavor. In swimming pools, we kind of talked about this as well. There's chemical reactions involving chlorine. Chlorine keeps the swimming pools clean and disinfected for swimmers. And when chlorine gets added to water, it produces hypochlorous acid. And it's this acid that will kill bacteria, it'll kill microorganisms by basically destroying their cell membranes and any of their inner enzymes. But just keep in mind, chlorine gas will have WHMIS symbols on it because it is dangerous when inhaled. It can even lead to unconsciousness or even death. So people that work with chlorine, they do have to protect themselves, make sure they're wearing protective rubber gloves, eye protection when working with chlorine. Another reaction that's common is digesting food. When we eat food and we digest it, that involves a series of chemical reactions. So, for example, in the mouth, when we eat food, especially like starches, like starchy foods, think of like bread, crackers, anything like that. The enzyme in our saliva, there's an enzyme called amylase. It'll start breaking down the starches into sugars right away. So sometimes it'll start tasting sweeter. It's because the saliva is breaking down starches into sugars in the mouth. Then we get to the stomach. There's another enzyme there called protease, and that enzyme speeds up the breakdown of proteins into amino acids. So proteins start getting digested in the stomach. And then as the food travels to the intestines, so here's the intestines, that's where another enzyme is there. It's called lipase, and the lipase will start breaking down fats into glycerol and fatty acids. All right, so we've talked about carbohydrates, started digesting in the mouth, proteins in the stomach, and then fats in the small intestine. And all of that involved enzymes, and all of those involved chemical reactions. All right, so that's it for 2.1. There's questions here to do on page 28, numbers 1 to 5.